This video summarizes the topics that we have discussed in these chapters. This entire chapter is about differentiations. First, we learn about that differentiations can be done through the first principles. The equations is given here. To the limit of theta x equals to 0, the changes in terms of the functions by theta x is to be divided by the theta x. You will substitute the equations of x plus theta x to be minus with fx. Expand the equations and cancel out each other as necessary. And then you will cancel out the theta x with the expanded expressions on top. Then the remaining expression here, you will substitute theta x equals to 0. The outcome of the analysis will be the f prime x. And this lays the foundations of the differentiations. In fact, the first principles for the differentiations can be applied for most of the problems of differentiations. However, the calculation steps is rather tedious and lengthy, especially when you encounter the functions which is more complex and having more than one terms. This leads to the list of the formulas for the differentiations of the common functions. You will need to memorize the formulas for the differentiations of the common functions, or refer to the tables or formula for those common functions. The tables normally give the differentiations for most of the simple functions, and they are given in most of the references on the mathematics. These equations for the common functions are normally used for the differentiations of a single term with only one functions. When differentiating more than one functions, you will need to use the product rules and the division rules. The product rules is used when the functions are in the relationship of the product, while the division rule is when the two functions is in the relationship of the divisions. These are the equations. For the product rules, it is u dv dx plus v du dx. As for the division rule, it will be v du dx minus u dv dx, entire expressions divided by v squared. Next, you will encounter some situations where there are functions within functions. In this case, you will need to differentiate the internal functions and the external function. The equations is given here. Normally, we will set the internal functions equals to u. Differentiate the function u to the dx, you get du dx. Rewrite the functions in the terms of u. Differentiate the u function based on the formulas from the common functions. With that, you have obtained dy du, and the du dx is also obtained at the early stage. You will multiply both of them, that gives you dy dx. This is as if the du part will cancel out each other. Next, you are also exposed to the successive derivations, where the functions can be differentiated at the first level, second level, third level, and so on. dy dx is differentiated from the fx, while the second level is differentiated from the first level, and the third level is differentiated from the second level. Next, you also learn about the implicit functions, where you have the difficulty to separate the y and x to the both sides of the equations. or you have y with the power more than 1. And it is also known that the function y here is also in the functions of x. With that, differentiating the function y, we have to incorporate with dy dx. This dy dx cannot be ignored because the y is also in the functions of x. Next, you learn about logarithmic differentiations. On top of the equations for the logarithmic equations, there are two more concepts that you need to know. First is the law of logarithma and also the calculation steps for the partial fractions. To solve this, normally you need to expand the equations in the forms of the log. And if the functions is too complex, you will need to use the partial fractions to expand and simplify them. After that, the entire expressions is differentiated. Logarithmic differentiations will involve a lot of differentiation in terms of the log. Differentiating the log fx will give you 1 per fx, and the differentiations of fx is to be put on top of it. And the last topic that you learn in this chapter is the parametric equations. The parametric equations exist when there is an existence of the third variable. On top of the x and y, there will be another variable such as theta. And normally they give you two equations, one for the x, another one for the y. Differentiate both x and y functions to d theta. Observe the relationship between the dy d theta and dx d theta. If it is a dx d theta, the divisions relationship is obtained. If the relationship is d theta dx, that means the product relationship is obtained. Use the respective equations for the product and the divisions relationship. These are the equations for the second level derivations, which is basically derivations from the dy dx to be divided or multiplied with dx d theta.